Hello, good people. Welcome to the first video. The first video here, as we get moving into the direction of power series, looking at series that aren't just made up of numbers being added together, but actual variable terms being added together infinitely forever, right? And so in the previous bridge video, I'm calling it a bridge video, we talked about the fact that there is a way to, at least in terms of the geometric series world, to equate a given function to an infinite series of polynomial terms, right? And later, and pretty close, I mean, it's coming up pretty close here, we're going to be able to show that e to the x, which is a transcendental function, we call it a transcendental function because it transcends the rules of algebra, right? You can't solve an exponential by adding or subtracting, multiplying or dividing. It needs something else. And for that, it needs a natural log. But e to the x is a transcendental function. However, we can make it algebraic by creating a never-ending series of x terms. And that's a power series. So a power series is a series whose terms have this pattern where I'm adding an infinite number of powers of x to the 0, x to the 1, x to the 2, x to the 3, and their coefficients aren't necessarily the same number, but they just keep going forever. So that's going to be our goal for this first video, is identifying what is the power series and then what is it centered around. Because we don't have to center the power series around 0, we can center the power series around any value. And so these first three examples are going to show us how we can tell. So if you look at this part of my notes here, or not my notes, but Tony's notes, it says I can identify the center of the power series because it's the number that I'm subtracting from the x inside the power of n. So when I look at my first example, what is the x value that I'm subtracting from x? Well, I don't see anything. So therefore, my center, or my c value, is 0. The other way to think about it is take the base of the n and set it equal to 0, and that's going to be my center. So the first series is centered at 0. But when I look at the second series, here my base is not just x, it's x plus 1. So my center is going to be different. And the way I can do that is set that base equal to 0 and then solve it out. And when you solve it out, I get negative 1. So my center, my c value, is negative 1. Or the other way to think about it, this is the number that I'm subtracting from x every time. If it's x plus 1, that's the same thing as x minus negative 1. And then finally, this is my base. So my base, set that equal to 0, solve for x, and there's my center. My c value is 1 because this is the number that I'm subtracting from x. It's a pretty easy task to find the center, but knowing where the center is going to help us as we find intervals of convergent for these power series. So in example 1, we just wanted to find the center. That's how you can find the center. We'll come back in the second video and we'll do some radius and intervals of convergence.